Hello and welcome to this repair tutorial, and today we're going to look at a Teac model number A-R650, and this is the Mark II amplifier. Specifications: power output RMS is 120 watts times 2, and that's delivered into a 4 ohm speaker load, and this drops down to 90 watts per channel into 8 ohms. You have the facility to select 2 sets of independent speakers. So this is done via the front fascia, just underneath the input selection knob, and this is A or B, both together, independent, or the deselect, none at all. And normally that's used if you connect to the headphone jack, which is just below the main power switch. Speaker range is from 4 up to 16 ohms, and then input sensitivity for your line inputs for MD tuner CD-AV aux, you also have tape as well, is 180 millivolts, and you can also connect directly a turntable input to it. So we're looking now at 2.8 millivolts in a 47 k ohm. Frequency response is 10 Hz to 65 kHz, and distortion is less than 0.02%, and this is on an 8 ohm load, 1 kHz at 45 watts. And you also have a line output at the rear, so that's delivering up to a maximum of 150 millivolts. Microphone input with its own adjustment for signal level, and that's just on the right hand side, right next to the volume control. You can also select from the front fascia direct mode, and the other feature is that you can mute the amplifier. And then overall dimensions, height wise is 142 millimeters, width 435, and depth is 355. And weight comes in at 9.2 kilograms. The amplifier is also supplied with a remote control, so of course you can adjust the volume control, you can also do the necessary input selection. Other features including placing the amplifier into standby mode. Now, what was the issue when the amplifier came into the workshop? Well, it's a very common issue, and it relates to the protection circuit associated with the reason for the failure. Sometimes you can get a failure of the power transformer on the primary, but not in this case. The issue was the left channel of the amplifier had failed. But just to go into how you actually determine, if the issue is with the transformer or if it's with the main amplifier board, the first thing to do is to just confirm that the T4 amp fuse, which is located on the startup board, has not failed. And commonly, even if the output stage of the amplifier fails or the transformer fails, you don't see that the input protection fuse is blown. Normally the transformer will go open circuit rather than short circuit on the primary. So it's up to yourselves how you want to verify that. So you could, for example, just disconnect the primary and then do a resistance measurement to confirm if it's open circuit or not. But just bear in mind that this EI type transformer does have a relatively low input resistance. The other method is that you power up the amplifier and then you use the startup relay to energize, but now what you would do is you would disconnect the secondary of the transformer from the power supply board, and that's what I'm showing here, this socket. If you do that, you'll find that the amplifier clears out of protection mode, so after about 5 seconds from power on, you'll hear the startup relay energize, and then you can use your multimeter just to measure the AC voltage on the secondary side. That really confirms, if you have that condition, that the fault is on the main amp board. Now when you look from the top of the amplifier, the right hand channel is on your left hand side and the right hand channel is on your right when you look from the rear, as I said. So disassembly of the amplifier is very easy. So you need to remove the back cover plate, and you have multiple screws left and right, and then also underneath, and then the associated screws which keep in place your RCA sockets, speaker protection or speaker terminals. And then because you can connect up auxiliary units to the device, it also has a power supply socket connector on there as well. And you'll find 2 Phillips panhead screws which hold in place the the power supply board, which has the large smoothing capacitors on. Now be aware that this has a common ground, so if you're going to do any form of testing after you've repaired the amplifier, you need to make sure that back cover plate is in place, the screws are fitted. If you attempt to do any power up, then you could damage the amplifier, or it may fail to actually come out of the standby mode. What I'm showing is the board on the workbench, And as I say, this is very easy to work on because it's more of a modular construction. And fault finding it isn't very difficult. And all these amplifiers commonly fail the same way. So what I'm showing here is an extract from the service manual, and then this is the left channel. And you'll see, and I'll put a link in the video, that I've repaired multiple units of these in more recent weeks, and I'll put the links to the other repair videos and tutorials, but you'll find that there's commonality here. So what you'll find is that either the left or the right channel, the output Sanken power transistors fail short circuit, and it could happen to both channels, or sometimes it just happens to the one. I think I've found probably more failures on the left channel, but for this amplifier, when you did look from the rear, you could see that there was some marking around the positive speaker terminal for the left channel. So I think what had happened is the user had accidentally shorted maybe the speaker wire to the chassis, and that's what had blown the output transistors. As always, try and source genuine originals. Don't go out there and try and source a component that looks okay, but it seems to be a fraction of the price. These output transistors are not obsolete or even end of line, so you can get them from reputable electronic parts suppliers. And in terms of price, you're probably talking about £3 to £4 in the UK, probably maybe $5–6, so not high. And then once you replace the two Sanken output transistors, just pay attention to the 5W 0.22 ohm emitter resistors. One of them is where you would then measure across, and there's a test connector on the board to set the bias. But even if the second emitter resistor hasn't failed, just change it anyway. You know, it's such a small value of resistance. You know, you'd probably need like a milliohm meter to measure it exactly. What you'll also find is there are bias resistors as well, and the bias resistor here is 100 ohms, and what it's done is it's failed an R33. Now, because I replaced both the Sanken output transistors, which was Q518 and Q520, and you can see 518 is a 2SC 3519A, and then the 520 is a 2SA 1386A. One of the output transistors, if you read it on the meter, read okay, but as is good practice, if you just simply have a failure of one output transistor in this arrangement, then it is best practice to replace both of the transistors. So that's what I did here, because if one's been subjected to high current, then the other one could and maybe potentially damage the transistor internally. So once the 100 ohm resistor was replaced, the two Sanken output devices and the emitter resistors, always verify that there's no other components that have failed. And I'll sort of show this, you know, within the video, where I've circled different components to highlight which components have failed. Some you can pick up on your multimeter, but some, you know, you just visually look at them and you'll see that they have failed. These are the resistors for the bias. And then to set the amplifier bias, what you need to do is just to make a test connector, because what you are unable to do is to put your multimeter probes into the test socket for the left channel. You have a restriction because the startup board is mounted above it, and there's two apertures. One way you can take an insulated adjustment tool for the trimmer setting, and then the other one is where I said you will need to connect this test lead and then back to your multimeter. Leave the amplifier running for about 20 minutes just to warm through, and then what you're able to do then is just to adjust it until it reads 5 millivolts, and repeat the same exercise also then for the right channel. You can also verify the DC offset, but for these amplifiers, you know, the DC offset was very, very low, you know, 2 to 3 millivolts. Now, once you've made the adjustment, just a point of note for the dim bulb tester. Don't undertake any work on any amplifier without a dim bulb, and I've put the link in the description below. When you first initialize the amplifier, there are large power capacitors which need to charge. So what you'll see is the dim bulb will light brightly momentarily, and then if you just press the standby button a number of times, it will effectively charge the rail capacitors up, and then it will then click, and then it will go on to full operation, completely out of standby mode, and the bulb will go dim. If the bulb remains very bright and every time you press the standby button it flashes bright, that tells you that you have another issue on the amplifier, and you would need to verify that. Here, once the board is on the bench, just because you don't see any visual damage on the right hand channel, just put your multimeter on the output transistors and make sure that none of them, you know, are reading 2 or 3 ohms, like base to emitter or collector to emitter. You can sometimes have a failure, but some of the driver transistors have not failed. Only the emitter resistors go open circuit and the output transistors then go short. So once that was done, then the amplifier went into test phase then. So of course you connect the test signal in there. And the second issue, again, is very common. So this is where you would normally have like an intermittent sort of loss of audio just on the left-hand channel. And it's got nothing to do with the repair that you've carried out or even the input selection IC. And if you used a signal tracer, you could verify that the signal was reaching the volume control stroke preamp board without issue. What I'm highlighting now is the multipin connector, which is located on this preamplifier stroke tone board, and the volume control board plugs into there. And what you can find is that the pins and the socket become oxidized and literally moving the board around slightly, and it's held in place if you remove the volume control knob by 2 screws. You can get the audio to return back, and then of course to duplicate the fault. So the way in which you just rectify this is twofold. First of all, just extract the volume control board, and then what I use is a fiberglass pencil just to brush the pins, and that removes any oxidization. And then I'll spray into the socket part on the tone board a high quality switch cleaner, for example De-Oxi. And then what I do is I locate the board pins back in, and I will plug in and unplug the board maybe 15 to 20 times. Once I've done that, that will clear off any oxidization, and then you can power up the amplifier and verify, and even moving the board slightly or quite robustly, there's never any issue with audio loss at all. So that just removes the secondary issue that you see. So as I said, I've put some links in the bottom or in the description for the video. By all means refer back to them, because there's multiple units which have recently been repaired, and you can take information from some of those repairs which apply to any 630 or 650, and also the predecessors of these amplifiers as well. So really that brings us to an end for this repair tutorial. So if you have any questions or you need any further information, by all means email audioamplifierservicing@aol.com, and I'll be very happy to come back to you and provide any guidance or support that you may require. So until the next time, I wish you well. Cheers and bye-bye.